Hello, my name is Ryan Blodgett. For our final project in EMEC 403, Ben Taflin, Zachary, Brambrink, and I decided to explore the CAM features within SolidWorks. This program feature is used to take a created part in SolidWorks and eventually output a G-code. This G-code will then load into a CNC-capable mill or lathe and perform the operations we specified automatically. We will demonstrate a few of these features of this program. To do this, we have created this short video that will showcase these capabilities on this simple drone frame. To begin the machining of this part, the stock must be accurately and firmly secured to the manufacturing machine to ensure precision and repeatability. For this example, and in most cases in the real world, a vise is used to clamp onto the stock. This vise has been pre-attached and located to the machine. Given the stock we have, the manufacturing of this part cannot be done with a single operation. We will start with a piece of stock slightly thicker than the drone frame itself. This stock member will be secured in the clamp and a facing operation will occur. This will bring the thickness down to the value required. Note, the parallels in the vise have been chosen to prop the stock just far enough off the vise to prevent damage during the facing operation. Next, 4 holes will be drilled to use as an attachment point for our next operation. Once these holes are drilled, the part will be removed and bolted to a jig plate. The vise assembly with this jig plate can be seen here. The plate acts to hold the drone frame while a contouring surface or contouring operation occurs along the edge of the part. By using this plate, we protect our vise from any damages that could occur during this operation. Ben will now explain how to program these operations in SolidWorks CAM.
Here we will be showing you a simple manufacturing process using SolidWorks CAM. This will be a milling operation. Shown here is our sample milling piece, a 4" by 4" drone frame with 1/8" hole arms. To start off, we will first go over to our operation tree and select the machine icon. There are 2 different available machine types in SolidWorks CAM, the first being milling machines and the second being turning machines, which Zach will cover with you later. For this process, we will be going through the milling operation with the inch. So we select that, hit OK. We go back to our operation tree. The next thing we want to do is set up our stock manager. We choose our 6061 T6 material, aluminum alloy, and the goal here is we have a y-axis offset right here, and what that does for you is it gives you a little bit of space between the main part and where you will be face milling it off later. This allows you to give the top of the part a nice smooth finish. So with a 1/10 of an inch of extra space allowed for face milling, we're going to continue. Next, you want to define your coordinate system. And here, the coordinate system allows you to decide which way the X, Y, and Z axis goes. Essentially, you want to have the Z axis going straight up and the X and the Y going along the stock box of a part. So there's the part bound box vertex that we can choose. We can also go with the stock bound box vertex. For this demonstration, we're going to be using the stock bounding box vertex and select this corner. As you can see in the small icon right here, the Z axis isn't facing up. However, you can select the box over here, select the top of the part, and the axis will correct itself. It's okay. Then it will update the operations that I already have put together. So today we'll be going through 3 unique operations, but 4 overall operations in total for this. So if you look over here to the left, you will see that I have suppressed all 4 of the features that we will be working on today. And that is so that I can do an in-depth walkthrough with you guys. So first we're going to go to a new setup. And here we want to select the plane that it will be top facing perpendicular to the cutter of the mill. So we're going to click this top surface here, click the check mark. And then if we go back to our operation tree, you can see that we have our new setup right down here. I've gone through quite a lot of them, so we're on number 15 now. And now for our first face milling operation, we're going to go to 2.5 axis mill operation. Make sure to select face mill. And then here we have a full list of tools that we can use, but we're going to use a 1/2 inch flat end. And then here we need to pick from certain features that are available or that we can create. So if we try to check that, it's going to give us an error because that is not in fact a feature, it is just a setup. So we're going to create a new feature, use the part perimeter feature. So as you can see here, this orange box is the stock piece that we're going to plug into the machining vise shown earlier that we're going to cut. Here's the excess 1/10 of an inch of material that will be face milled off in this process. So walking through the feature tree, we're going to select open pocket, rough finish, and then for the end condition, we want to tell the program what area it has to cut. So we're going to try to get these dotted lines to go from the top of the part to the top of the stock piece. So if we do top of the part, you will see that the dotted lines match up to where we want to cut. You can press check. It'll bring us back here and have that perimeter open pocket checked. So we're going to go with that. And now a window will open that can give you a lot more advanced features. So here's a lot of the tooling numbers that you can alter yourself if you want to. We also have the feeds and speeds, courtesy of SolidWorks. It actually fills in the speeds and feeds for you, which saves you a lot of pain. So that's awesome. And then it also gives you certain cutting restrictions that you can type in yourself and several other details that I don't want to get into today. So we're going to select OK. And now we have our face milling operation coded in. However, there's no toolpath. So what you want to do is now we can generate a toolpath with this selected. So after generating the toolpath, you will see the physical toolpath that the cutter goes over the part with. There are 2 lines and the tool will go over it twice. And if we simulate the toolpath, then it will create a box around the part, and that shows the excess material of the stock, and the darker is obviously the drone frame in the middle. We're going to put it up to full speed, and if you press play, the cutter will go through the entire operation. And if you go down to the side here, you will see that it cut down to exactly where we wanted it to. You now have a perfect 1/4 inch thickness of the drone frame. With the face milling operation now wrapped up, we can check out of the simulate toolpath. The next thing we want to do is drill out the holes for each of the 1/8 inch holes on the frame arms. So to do that, we're going to go to hole machining operations. This is still the same setup as the face mill, bear in mind. We're going to do a center drill to get the first peck mark in for the main drill later as an accuracy precaution. We're going to go ahead and select the first center drill that we find. We're going to go over to features, and similar as before, we need to create a new feature. This time we can actually go in and select sketch number 4, the same sketch that you used to actually extrude cut out those holes. Then we can go over to the end condition, and similar as before, you're going to want the same cutting area as before here. So we're going to go ahead and just select the thickness of the part, press enter, and as you'll see, those holes go all the way through. So we're going to go ahead and click the check mark here. And then all the same options come up as before. We're going to go ahead and just press OK. Now if we go ahead and generate this toolpath and simulate the toolpath, it's going to go through our first operation, and then it'll show us the center drilling operation. However, if we go back, we're going to see that it doesn't just peck the hole into there, it goes all the way through, which is not what center drills are for. So in order to fix this, we're going to check out of the simulating toolpath, and we're actually going to go in and edit the center drill function. So as you see here, we get all of our options, and for this, we're going to sort through all the settings in order to find the depth of cut that we want. We got top of stock, top of feature, feature options. So as you can see here, we have our machining depth of a 1/4 inch. This isn't actually what we want. So we're going to go ahead and press the override button right here. And since we just want the top bit of the drill to go through, we're going to change it to 50 thou. Select OK. Regenerate the operation, or the toolpath rather, and then simulate the toolpath again and see what happens. A little laggy sometimes. And as we'll see, if we press the back arrow, it goes in just as far as we want it to. And another way to verify that is if you go to the end of the operation, you can actually look into the hole. And as we'll see here, it's a little bit fadey, but you can still see it. It packs in just as much as it needs to in order to start the hole. So now that we have successfully created a center drill mark here, we're going to check out of the simulation. For our third operation, we're going to go ahead and finish drilling these holes here. To do that, we're going to go back to the hole machining operation. Make sure that you have drill selected. For hole, we're going to select this T17 one down here, 1/8 of an inch for the holes. I know it says 0.13, but it is in fact an 1/8 inch diameter drill. It just says 2 decimal places because that's what SolidWorks rounds to on standard. Over our features, we're going to select our hole group 6, which is the same one that we did for our center drill. This has the same end condition as before, so it works for us. So we're going to click the check mark here. And now you'll see that our options box comes back up. So if you look here, it takes us to feature options automatically. We want to make sure that the machining depth is at 1/4 inch, which is again the thickness of our frame here. But this time we want to make sure that we add in the tip length so that the tip goes all the way through the hole, making it a uniform straight hole. So now we're going to select OK, generate the tool path, and simulate the tool path. Then we're going to play through the whole thing again. And to make sure that the drill went all the way through, we're going to check on the bottom, and you'll see that yes, in fact, it went all the way through. That is a nice and smooth, it's a nice and smooth hole. So with that, we're going to check out of there and move on. Now for the last operation in this tutorial, we're going to go ahead and do the contour cut around the edges of this drone frame. So to do that, we're going to go back to 2.5 axis mill operation. Make sure to select the contour mill. For the tool, we're going to roll forward with the 1/4 inch flat end mill. And now for the features, we have to make one that goes all the way around. So we're going to go ahead and create a new feature for the part perimeter. Now here we're going to select the top of it, click new feature, and now we're going to select boss. And now since it's going from the top and down to the end condition, the bottom of the part here, the blue lines fully encapsulate the area that we want cut. So we're going to go ahead and click the check mark. Click the check mark again with the perimeter boss checked. And then there's nothing we need to modify in here, so go ahead and press OK. Once that's finished, we're going to go ahead and generate the tool path. And now we're going to simulate the tool path. And after running through the other things, it shows that the contour does in fact go all the way around the part and create smooth finishes on the outside. Now if we go back and simulate the tool path by right-clicking on there, we can see an isolated view of it, and that it does in fact go all the way around the part on its own. So we're going to check that. So now that all the operations are complete, that concludes the tutorial for the milling operation. Thank you.
SolidWorks CAM for CNC lathes is very similar to that of CNC mills. In order to switch over from mill configuration to lathe configuration, come up where it says machine in your feature tree. We're going to right click, go to edit definition, and then under machine we'll see all the different machines that are loaded that we expect to be working on. So here we'll click select on the turning machine and hit OK. In the same area we can also adjust our tool crib, which would be the number of loaded tools that we expect to be using in an operation. We can define this now or we can define this later on. Coming down into the stock manager, we want to set this up so that we have a cylinder bar stock that is just oversized to our part so that we can cut down into it. Here we have our parameters which adjusts the size of our stock. We have radial, axial, and length, and then offset parameters which will increase based off of extra material we want to have on the stock. Now our coordinate system needs to be set up such that the x-axis is lateral across the part, y-axis is vertical, and z is coming into or going out of the spindle. Now, in order to set up actual cutting procedures, we need to come up here into either turning operations, groove operations, or bore operations. We're going to start with turning operations and just demonstrate setting up this facing cut here. So in this case, we'll be doing a face finish because we won't be removing very much material. Under tool, this is automatically selected and it'll do just fine, but we can come into add new and create our own tool or choose from a variety of others that have been predetermined. And then under features, you go to create a feature. We want to click this face and you can see it highlights this line which shows the cutting path of the part. And this line here is a symmetric view of the cutting path allowable. If the cutting path doesn't line up with your part itself, then you have conflicting geometries and the tools you have specified won't actually be able to cut into it and create what you want. So now that we're here, we have it set up, we have our face chosen, we hit OK, and then it'll appear here. We'll hit OK as well. This is the actual face that I have set up from previously, and in order to actually finish it, you'll need to right click and click generate toolpath, otherwise it won't have generated one automatically. Next we have a turn finish. This will just be applying this chamfer here using the same tool. It'll come in and it'll cut the same way, and to do so we went into the same process. I went into turning operations. Here you do a turn rough or a turn finish, and then under tool you would select the same one in this case, as it doesn't necessarily matter, and then you pick this chamfer and it'll appear as this line because once again this is the cutting path that the tool can follow. Next we selected both these two faces because this procedure will be conducted all at once, and using a larger tool, the 80-degree carbide end bit, the tool was not able to actually reach the entire geometry, and therefore this pink line appeared further out and would not cut all the way in. In order to mediate this, we chose a 35-degree carbide end bit, which allows for more close cuts and more finer geometries to be cut into this part. As you can see, this will occur in multiple passes as it's working the stock down to its final shape. To demonstrate the boring operations, we've come in and we've added a center drill process, which will bring the center drill into this hole. And when we're setting up a boring operation, or a drilling operation, in this case we'll choose drill just to demonstrate. Our tool will say we're using this 3/4 inch drill once again. And features, when we go into create a feature and you select a bore, you're picking the inner diameter of this bore, so it'll appear as this line here, but it will center up your drill bit based on the geometry that it's attempting to cut. So in this case we came in with a center drill and finished with a 3/4 inch drill just to demonstrate the ability of the machine. So once we think that we have all of our cutting procedures set up, we are going to make sure we have toolpaths generated for all of them, and then come up to simulate toolpath. And then here you can dictate the speed of your toolpath and you can adjust transparency of stock. But when we hit go, you can see the tool comes in, faces, and creates the chamfer, and then the 35-degree end mill, the 35-degree lathe cutting tool will slowly create these geometries in multiple passes, which increases your overall tolerances and your surface finish of your part. And then the center drill, and then the final drill. And it's that easy. Anyway, thank you very much. Hope you enjoyed our lecture on how to do CAM for SolidWorks. We know this is a rough intro, but hopefully this will be a good starting point. And from here you guys can come in and practice, learn some more, and if you have questions, feel free to reach out. Thanks.